Hello friends, welcome to Risingpearl.com. This is series 8 where we are learning a lot about arithmetic progressions. Friends, this is webisode number 5 and today we are going to continue to take a look at how do we solve questions on arithmetic progression. This is part 3. So specifically the type of questions that we are going to focus on in this webisode is the given series an arithmetic progression? So we will be given a set of numbers. We have to determine if that series is really an arithmetic progression. And let's say if so, we have to find out the first term and the common difference. So friends, I hope you're following us along at Risingpearl.com. We have started this brand new series just recently, and in the first 2 webisodes we talked about what is arithmetic progression and what are some of the common terms, the first term, the common difference, etc. of an arithmetic progression. How do we write these terms, and also what is the general form of writing an arithmetic progression. Then in the last 2 episodes we have been looking at what kind of questions that you may see on arithmetic progressions and more importantly how do we solve them. So let's take a look at these kind of questions in this episode and how do we solve such questions. So the question goes like this. Is the given series of numbers an AP? AP is a short form for arithmetic progression. If so, find the first term and the common difference. So we have to the question has 3 parts. First, it's a yes, no. So is the given series a arithmetic progression? So if answer is a yes or a no. If it is yes, we have to find out the first term and we have to find out the common difference. So and then also we have to find out 2 more terms of that expression, that arithmetic progression. So the first question, so the first series is given like this. So what we know is that A, which is the first term, is 2, which is given. A2, which is a second term, which is 5 by 2. 5 by 2. The third term is A3, that is 3. And the fourth term, which is A4, is 7 by 2. So we know what is the test to say the series is arithmetic progression or not. Simply we have to do A2 minus A1. We have to do this for each of these terms. So we take the second term and we subtract the first term from it and see what we get. A2 minus A, this will be 5 by 2 minus 2, or in other words this will be 2 is a denominator. So 5 minus 1 2s are 2, 2 2s are 4. So this will be 5 minus 4 or 1 by 2. That's fine. Now we will do A3 minus A2. A3 minus A2. And what we are hoping is we are trying to find out if this difference A3 minus A2 is same as A2 minus the first term. Right? So we are hoping this difference is going to be 1 by 2. So let's do this. So we have 3 minus A2 is 5 by 2. So if we solve this, the denominator is 2. Now here it is 1. So 1 2s are 2, 3 2s are 6 minus 5 or 1 by 2. So far it is a good news that A2 minus A is same as A3 minus A2. There is one last term that we have to check, because remember we have to check all the terms. If this kind of question is given, you have to check all the terms to make sure that all of the common differences have the same value. So the last one would be A4, this is the fourth term, minus A3. And we are really hoping that we get 1 by 2. So let's do this. So we have 7 by 2 minus 3. So 2 is the denominator and here we have 1. So 7 minus 1 2s are 2, 3 2s are 6. And voila, yes, we actually see the common difference is really the same for all the 4 terms which is given in the series. So we say yes, yes, this is a arithmetic progression. So this set of numbers is a arithmetic progression. Now that we have found out, so the first term is given by number 2, which is the first term, and the common difference as represented by D is equal to 1 by 2, as we can see here. Now we have 1, 2, 3, 4 terms. If we have to find 2 more, we have to find out A5 and A6. So A5 will be, we take the fourth term, A4 plus D. So A4 is 7 by 2. So we have 7 by 2. We add 1 by 2, which is a common difference, right, to that, and denominator will be 2. So we have 7 plus 1, which is 8 by 2, or this will be 4. So the very next term, the fifth term will be 4, and similarly, because we have to find out 2 more terms, the sixth term will be 4, which is fifth term, plus common difference. So if we solve this, we will get 4 2s are 8 plus 1, 9 by 2. So the fifth and the sixth term for this series will be 4 and 9 by 2 respectively. Let's take a look at one more question. So same question, is the given series AP? If so, find the first term, common difference, and 2 more terms. So what is the series which is given? Say this is the series which is given to us. So as we can see, the first term clearly is 3, right? This is the first term. And please note that second term is this. So second term is this, that is in between these two comma, is the entire thing is your second term. So A2 is going to be 3 plus square root 5. Similarly, A3, which is given as 3 plus 2 square root 5. 3 plus 2 square root 5. A4, which is given, is 3 plus 3 square root 5. 3 plus 3 square root 5. So we will approach this question exactly the same way. So we will say that let's do A2 minus A. So I'm taking the second term and subtracting the first term from it. So A2 is this, which is 3 plus square root 5, and I'm going to subtract the first term, which is 3. So if I do that, plus 3 minus 3 will cancel out, and I am left with square root 5. Now I will do A3 minus A2. Remember, we cannot be complacent to say, well, we did that, and yes, it is arithmetic progression series, or it is not. We have to make sure that the common difference for each of the term minus the previous term, we have to find out each common difference and make sure they're all the same value. So A2 minus A is square root 5. Now we are doing A3 minus A2. So we are taking a look at this term. This is A3. A3 minus A2. So A3 is 3 plus 2 square root 5. This is A3 minus, we will write it in a bracket because we have 2 terms. So A2 is 3 plus square root 5. 3 plus square root 5. So plus 3 minus 3 will cancel out, and 2 square root 5 minus square root 5 will be 1 square root 5. So we have 2 square root 5 minus square root 5 will be 1 square root 5, or simply square root 5. So far this is good news, because second term minus first term is square root 5. Third term minus second term is also square root 5. So let's take a look and see the last term, which we have A4 minus A3, what we get here. So A4 is this entire term. This is A4, right, as we have written here. So A4 is 3 plus 3 square root 5. So this is A4 minus A3 is 3 plus 2 square root 5. So if we open the bracket, so plus 3 minus 3 will cancel out, and 3 square root 5 minus 2 square root 5 will be 1 square root 5, or simply square root 5. So this is amazing that this series is also a arithmetic progression. So yes, this is also a arithmetic progression. So this is a yes. And what is the first term? Clearly the first term is 3. And what is the common difference? Common difference is square root 5. Square root 5, because we notice that common difference for all the terms, each of the term and the preceding term, the difference is square root 5. So D, the common difference is square root 5. So if it is a AP, now we have to find out two more terms. So simply let's write it here. So A5 will be, we will take A4, which is this 3 plus 3 square root 5, right? This is A4. We will add the common difference, which is square root 5. So if we do that, we get 3 plus 3 square root 5 plus 1 square root 5 will be 4 square root 5. So similarly, if this is A5, so as we can imagine, so A6 will be simply A5 plus D. D is the common difference. So A5 is this. So let's write this here, 3 plus 4 square root 5, which is A5, and we add the common difference to it. So 4 square root 5 and 1 square root 5 will be 5 square root 5. So we have 3 plus 4 square root 5 plus 1 square root 5 is 5 square root 5. So yes, this series is an arithmetic progression, and first term is 3, the common difference is square root 5, the fifth term is 3 plus 4 square root 5, and the sixth term is 3 plus 5 square root 5. So friends, now let's see if we have time, maybe we can take one more question. So let's say if we take a look at this particular series. So the numbers are given like 0.3, 0.33, 0.333, 0.3333. As we can see, as we keep going on adding terms to this, we are increasing one extra 3. So let's find out. So the first term is obviously 0.3. The second term is going to be 0.33. Third term is going to be 0.333. And the fourth term, what we have been given, there are 4 3's, so 0.3333. So to test if it is a AP or not, so we will do A2 minus A, so which will be 0.33 minus 0.3. So if you do that, so if you do 0.33 minus 0.3, 0.3 means 0.30, so we will get, this will be 0, so 0.03. So this will be equal to 0.03, right? Now let's do A3 minus A2. So now we are doing A3 third term minus the second term, and see what we find. So this will be 0.333 minus 0.33. So let's do this. Let's write it here. 0.333 minus 0.33. So we can add a 0 here. So this will be, so here we get 3 and then 0, 0, 0, 0.0. So this is actually equal to 0.003. So one very interesting point that we notice is that A2 minus A1, or the between the second and the first term, the difference is 0.03. But the difference between third term and second term is 0.003. So we clearly see that 0.03 and 0.003, they are not equal. That means the difference between these two numbers and these two numbers, they are not equal. So this series is not arithmetic progression. So this series is not an AP. So at this point we don't even have to do A4 minus A3. We don't even need to do A4 minus A3, because we have already found out that these two are not matching up. The common differences are not the same, and hence we conclude this is not an AP.